Hi, so we're going to work on Unit 4, Opener number 1, where we're working on solving for a single variable in an equation that has a variable on both sides. So you'll notice here in problem 1 we have x's on the left side, but we also have these x's on the right side. So somehow or another we have to get them all on the same side. One thing that's a good way to start this is just to distribute this to get rid of these parentheses. So I'm going to do that and get 28 minus 6x equals 8. Now you'll notice this negative sign is just sort of floating around out here in front of this set of parentheses. So I like to think of that as a negative 1 being distributed into those parentheses. So it'll be 8 minus 6 minus 4x. Now I'm just going to combine some like terms here, so I'm going to do 8 minus 6. So I'll have 28 minus 6x equals 2 minus 4x. And now I'm ready to start thinking about how am I going to get all of these variables on the same side. So you need to cancel out the x's on one side or the other. So in order to turn this negative 6x into 0, I could add 6x to both sides. And that's one way you could do the problem. If you prefer, you could add 4x so that you'll be canceling out the x's on the right-hand side of the equation. And you would also add 4x to the other side. So I'm going to just stick with that. On the right-hand side, negative 4x plus 4x is 0. So I'm left with just a 2, because 2 minus 0, of course, is just 2. And then on the left side, I'll have 28. Now I've got negative 6x plus 4x, which will give me a negative 2x. So I just need to now get this x by itself. So I'm going to subtract 28 on both sides. And again, 28 minus 28 gives me 0. So I have negative 2x equals 2 minus 28 would give me negative 26. And to get this x by itself, you'll notice it's being multiplied by negative 2, so I'll have to divide both sides by negative 2. And I end up with x all by itself on the left side, and negative 26 divided by negative 2 gives me a positive 13. Okay, now if you want to pause the video so that you can try the second problem before I do, go ahead, pause it, give this second problem a try. But I'm going to go ahead and do the second problem now. Okay, again, when you're solving an equation, it's generally a good idea to do what you can on one side. So we're going to use the distributive property here in order to sort of simplify each side. So I'm going to multiply that 3 times the quantity x minus 7 and get 3x minus 21. And then over here, I guess probably a smarter idea would be, why not combine this 6 and this 7 first? So I'm going to leave that 2 there. Now this is a 6, and this is a plus 7, and 6 plus 7 is 13. I realize that there's a minus sign here, but that minus is what's happening with this x. Okay, that is a positive 6, and 7 is being added to it, and then this minus x is still there. And then there's a plus 14 out here. Oops. Plus 14. Okay, so now we've got 3x minus 21 equals, now I'm going to go ahead and distribute this and get 26 minus 2x plus 14. Again, I've got some like terms here that I can combine. This 26 and this 14 I can put together. So I want to put those together before I start bringing one side to the other. So 26 plus 14 is going to give me 40. And then the minus 2x is still there. Alright, well, just like in the last problem, I now have x's on both sides of the equation. I need to get them all on one side of the equation, which means I have to get rid of them. on one side. I think I'm going to do it by adding 2x to both sides. So negative 2x plus 2x is 0. 3x plus 2x on this side is going to give me 5x minus 21 equals 43. And then we just finish this out now that we've got all the x's on the same side. This 21 is being subtracted, so I'll have to add 21 to both sides. 5x equals 61. And this 5 is multiplying the x, so I have to divide both sides by 5 to get the x by itself, and x equals 61 fifths. So the big idea here when you're solving an equation that has variables on both sides, what you need to do is get the variables off of one side and get them all together on the same side.